Hi, welcome to Carnival. So in this episode of the LeetCode series, we are going to solve the question of climbing stairs. So here we are given a very simple question. You are climbing a staircase. It takes n steps to reach the top. Each step or each time you can either climb one step or two steps. In how many distinct ways can you climb to the top? It's a very simple question. For example, let's say we have 5 staircases. Okay, so n is equal to 5. Okay. With this, how many distinct ways are there in order to reach from 0, that is the ground, until the last top of the staircase? You can go like 1 plus 1 plus 1 plus 1, that is a way. So at each and every time you are taking just one step. But they have also given us you can also take 2 steps, right? So in that case, you can jump 1 stair and then in the next executive stairs you can always climb 2. So 1 plus 2 plus 2, that is also equal to 5. In this fashion, you have to find the total number of ways. In how many distinct ways can you climb the stairs? Let us start by taking a very simple example and then we'll build up the problem. It's a very simple problem based on dynamic programming. So stay until the end of the video to understand this completely. So here we have a staircase and we also have a person, and let's name him just Prince. Okay, so this Prince must go to staircase 2 or step 2, and now he is in step 0. So how many distinct ways does he have? Obviously he can go from 0 to 1 and then 1 to 2, taking one step at a time. So that is obviously a case, and that involves 1 plus 1. This is way number 1. Now what does the other ways that he has? He can directly jump to 2, right? We can also take 2 steps at a time. So that is our next way, directly go from ground all the way until the second step. So that is our second way. So there are totally 2 ways in order to go to step 2. Now let us move on to the next part. Let's say our Prince want to move to step 3. How many distinct ways does he have? He can always start with going 1 step at a time. So 1 plus 1 plus 1 is always an option. What are the other ways do we have? You can always go directly from 0 to 1 with 1 step and 1 to 3 with 2 steps. So 1 plus 2 is also a solution that would lead us to 3. Okay, and similarly the reverse of it, directly from 0 to 2 and then 2 to 3 is just 1 step. So 2 plus 1 is also a solution for us. So these are the distinct ways for our Prince to move from the 0th position all the way until the 3rd step. Okay, so with this observation, let us generalize this and try to find a pattern to solve this question. So if we want to go to 0 step or 0, how many distinct ways do we have? We are already in ground, that is the 0th level or 0th step. So how many ways do we have to go to 0? Just stay there. That is a single one way that you have. Okay, if you move 1 step, you will move to 1. Again, you can't come back to 0. And if you take 2 steps, you will always take again, you move to the second step, you can't come back to 0. So the only single way possible to be at 0 is to stay there itself. So that is the single way you can to stay at 0. Okay, so that is the value if n is equal to 0. If there are no steps, then how many ways are there to reach 0? That is just one way, just stay there. That is the single way. Okay, so if you have the value of n is equal to 1, there are 1 stairs. In that case, how many different ways do we have? You are at 0, you can jump to 1 with just 1 step. So that is the single way that we have. If you move to 2, you can't come back to 1, and the other options are just moving to step 1, right? So you can either go with step 1 or step 2. Here if you go to step 2, you can't come back to 1. Since our final destination is 1, we are keeping it until only from 0 to 1 with a single step. So that is also we are having just a single option. Moving on to the step 2, if you want to move to step 2, as we saw earlier, you can move 1 plus 1 or directly to 2. So there are totally 2 ways in order to move to step 2. And similarly for step 3, 1 plus 1 plus 1 or 1 plus 2 or 2 plus 1. As we saw earlier, there are totally 3 ways to do that. As you can see here, 1, 1, 2, 3. What is the pattern that we recognize? This exactly resembles a Fibonacci sequence. So how does that happen? For each step, how did we come into this formation is because, let's say you are in the 10th step. In from where could you have been come to 10 step? You can either come from 9 to 10 by taking a single step, or you can come from 8 to 10 by taking a 2 step, right? So if you want to go to 9, you can come from if you want to go to 10, you can come from 9 by taking a step, or 8 from taking 2 steps. So the total number of ways you can reach 9 plus the total number of ways you can reach 10. If we add these two, you will get the value for total number of ways to reach 10, right? So similarly, for each and every iteration, if you want to move to 8, in that case, you can move from 7 to 1 step 8 or 6 to 2 step 8, right? In both of these cases, what do we get the value of 8? Value of 8 is equal to number of ways to reach 7 plus the number of ways to reach 6. If you add them both, you get the value of 8. This is similar to permutation and combination, the sum rule that we used to learn, So to reach the nth step, there are totally 2 ways. So there are n1 ways to reach the first 6 and n2 ways to reach 8. If we add these two, we will get the final result. So this sum rule is also being applied here. Now permutation combination, you can always ignore that possibility. Just stick on to that this resembles a Fibonacci sequence for the simplest case. But essentially, what process that goes in here is, we are forming a recurrence relation which says that f of n is equal to f of n minus 1 plus f of n minus 2, which means that to reach step n, you can either take n minus 1 steps and then reach plus 1 and reach n, or you can come from n minus 2 and then take a 2-step jump. So n minus 1 plus n minus 2. Why there is an f of n minus 1? Because to reach n minus 1, you have, let's say x number of ways, and to reach n minus 2, we have y number of ways. So x plus y will give us the number of ways to reach the given number n. Okay, so this is the recurrence relation. As we saw earlier, if you want to reach 10th step, the total number of ways to reach 9th step and the total number of ways to reach 8th step, both of these combined together gives us the answer for nth step. So that fashion is being applied here. So this logic is going to be applied, and finding a Fibonacci sequence using dynamic approach is being used here. Why dynamic programming? I tried solving it using just a normal divide and conquer approach of using recursion to find a Fibonacci sequence, but that led me to the runtime exceeded error. Okay, so LeetCode does not allow more than a set given limit as runtime for this question, and hence I moved on to dynamic programming approach. Okay, so 0, 1, 2, 3 is the given numbers. For 0 and 1, we set it by default as 1, and for second, you can always do the formula that we learned. Okay, so f of n, here f of 2 is equal to f of 1 plus f of 0, and similarly f of 3 is equal to f of 2 plus f of 1. Okay, so 2 is equal to 0 plus 1, which is 1 plus 1, 2, and 3 is equal to the value at 1 and the value at 2, which is 1 plus 2, 3. Similarly, what would be the value at 4? Obviously from the formula that we learned, pause the video and try to answer this question in the comment section below. And while you're up there, don't forget to click the subscribe button. So obviously for the answer 4, we have to add f of 4 is equal to f of 3 plus f of 2. You can either come from third step by taking a single step, or you can come from second step by taking 2 steps. So in this fashion, f of 4 is equal to the value at 2 and the value at 3. So 2 plus 3 gives us 5. So f of 4 is equal to 5, and that is the answer to this question. So similarly, using this recurrence relation of f of n is equal to f of n minus 1 plus f of n minus 2, that is the Fibonacci sequence relation, we are going to solve this question. So if you are thinking that this recurrence relation and dynamic programming concepts are really irritating or hard to understand, you can just ignore them and just see that this resembles a Fibonacci sequence, and hence we are applying Fibonacci sequence. Okay, but what's the catch here? You want to use an array, and we are going to store the Fibonacci numbers in an array in order to find the next value. Okay, so if you want a value of 4, all you do is add the previous 2 elements. Okay, so that is the algorithm that is given here. So create an array of size n plus 1, so 0 until the value that we need. So there are totally n plus 1 elements including 0. The first, as we know, that array of 0 and array of 1 is set by 1 as default by us. we know that the series starts with 1 and 1, so we are assigning 1 by default, and we are going to loop until from 2 until n. Okay, in all these iterations, what is the operation that we are going to perform? So array of I is equal to array of I minus 1 plus array of I minus 2. F of n is equal to f of n minus 1 plus f of n minus 2. The same concept is being applied here. So array of I is equal to array of I minus 1 plus array of I minus 2. Exact formula for a Fibonacci sequence. Okay. So using this algorithm, we are going to solve this question. The last element that we get, and that is our output. So f of n is our output. Let's move on to LeetCode and try to solve this algorithm. So what was our first step? Our first step was to create an array. So let's create an array. So int array is equal to new int of n plus 1. So it starts from 0 and all the way till n. Okay. So what's the second step? As we know, we have to initialize the value of 0 and 1 to 1. And we have to do that manually. So array of 0 is equal to 1 and array of 1 is equal to 1. So we have set these two by default. From this third iteration, or from I is equal to 2 all the way until n, right? So you can write it as I less than or equal to n I plus plus, or there is an easier way to do this. Instead of less than or equal to, you can just say I less than n plus 1. So it starts from 2 and goes until n. Okay, so it is same as the other approach, but whenever you use less than or equal to, each iteration it must compare less than as well as equal to, which takes an extra step. So this is more efficient than using less than or equal to, and that is why I'm using this. Okay, but each iteration, what do we do? Array of I is equal to array of I minus 1 plus array of I minus 2. So this is gonna be our main gist of the code. At last, what do? We return the value at array of n. That is the last value. Okay, so this is gonna be the code to solve this question of climb stairs. Now let's run this code and verify whether it works for sample test cases that are given here. There are at least 2 sample test cases, I guess. We have passed the sample test cases. Now let's submit and verify it with all the other test cases that we have. And congratulations, you have solved the question of climbing stairs with us. So if you loved this video, please drop a like and comment down below if you have any questions, and see you in the next episode of LeetCode series. Until then, bye bye.